Welcome to Math is Beautiful. In this video, we are solving the complete Chapter 2, Physics and Mathematics, from Concepts of Physics by H C Verma, Volume 1, both objective sections and all 35 exercises. We begin with Objective 1, 6 multiple-choice questions on the basic nature of vectors. Here they are, exactly as in the book. Pause if you would like to attempt them first. Objective 1, Question 1. A vector is not changed if Option A. It is rotated through an arbitrary angle. Option B. It is multiplied by an arbitrary scalar. Option C. It is cross-multiplied by a unit vector. Or Option D. It is slid parallel to itself. What does this mean? We must find which operation leaves both the magnitude and the direction untouched. A vector is defined by its magnitude and direction. Rotation changes the direction, so Option A changes the vector. Multiplying by a scalar changes the magnitude. The vector changes. An A cross product produces an entirely new perpendicular vector, changed again. Sliding a vector parallel to itself keeps both magnitude and direction. A vector does not depend on its location. Hence, the correct answer is Option D. Question 2. Which of the sets given below may represent the magnitudes of three vectors adding to 0? Option A, 2, 4, and 8. Option B, 4, 8, and 16. Option C, 1, 2, and 1. Option D, 0.5, 1, and 2. What does this mean? Three vectors summing to 0 must form a closed triangle, so every side must be at most the sum of the other two. Check the triangle condition for each set. The largest magnitude must not exceed the sum of the other two. In set A, 2 plus 4 is 6 less than 8. The triangle cannot close. In set B, 4 plus 8 is 12 less than 16. It fails too. And in set D, 0.5 plus 1 is 1.5 less than 2. It also fails. In set C, 1 plus 1 equals 2 exactly. The three vectors can lie along a line, a degenerate closed triangle. This works. Hence, the answer is Option C. Question 3. The resultant of A and B makes an angle alpha with A and beta with B. Option A, alpha is always less than beta. Option B, alpha is less than beta if A is less than B. Option C, alpha is less than beta if A is greater than B. And Option D, alpha is less than beta if A equals B. What does this mean? We must decide which vector the resultant leans towards. The resultant of two vectors always lies closer to the bigger one. The bigger vector dominates the sum's direction. Closer to means a smaller angle with A. Alpha is less than beta exactly when A is greater than B. Hence, the answer is Option C. Question 4. The component of a vector is Option A, always less than its magnitude. Option B, always greater than its magnitude. Option C, always equal to its magnitude. Or Option D, none of these. What does this mean? A component is the magnitude times cosine theta. We must see what values it can take. The component along a direction at angle theta is a cosine theta, which ranges from minus A to plus A. So it can be less than the magnitude, equal to it when theta is 0, and even negative. None of always less, always greater, always equal holds. Hence, the answer is Option D, none of these. Question 5. A vector A points vertically upward and B points towards north. The vector product, A cross B, is Option A, along west. Option B, along east. Option C, 0. Or Option D, vertically downward. What does this mean? We must apply the right-hand rule to up cross north. Set up axes. East is x, north is y, and up is z. Then A is along z and B is along y. K hat cross J hat is minus I hat. The product points along the negative x direction, which is west. Hence, the answer is Option A, along west. Question 6. The radius of a circle is stated as 2.12 centimeters. its area should be written as option A, 14 square centimeters, option B, 14.1, option C, 14.11, or option D, 14.1124 square centimeters. What does this mean? The area must be rounded to as many significant figures as the given radius. The radius 2.12 has 3 significant figures, so the result of the calculation must also carry 3. The area is pi r squared. Pi times 2.12 squared, which is 14.1124, rounded to 3 figures, 14.1 square centimeters. Hence, the answer is option B. Next, Objective 2, 5 questions where more than one option may be correct. Here they are. Pause here if you want to try them yourself. Objective 2, Question 1. A situation may be described using coordinate axes of different orientations. Which of the following do not depend on the orientation of the axes? Option A, the value of a scalar. Option B, a component of a vector. Option C, a vector. Or option D, the magnitude of a vector. What does this mean? More than one option can be correct here. We must test each. A scalar has no direction, so its value cannot depend on how we orient axes. Option A is correct. A component is a projection ONT, O an axis. Rotate the axis and the projection changes. Option B depends on orientation. The vector itself is an arrow in space. It exists before any axes are drawn, so option C is correct. And its length does not care how we tilt the axes either. Option D is correct. Hence, the answers are options A, C, and D. Question 2. Let C equal A plus B as vectors. Option A. C's magnitude is always greater than A's. Option B. It is possible to have C's magnitude less than both A's and B's. Option C. C is always equal to A plus B in magnitude. Or option D. C is never equal to A plus B. What does this mean? We must remember the triangle inequality and its extreme cases. The magnitude of a vector sum ranges between the difference and the sum of the magnitudes, depending on the angle. Two nearly opposite vectors nearly cancel. C can be smaller than both A and B, so option B is possible. And since C can be smaller than A, option A's always greater claim is ruled out. C equals A plus B in magnitude only when the vectors are parallel, so always is wrong. But parallel vectors do achieve it, so never is wrong too. Hence, only option B is correct. Question 3. The angle between two non-zero vectors, A and B, is 120 degrees, and their resultant is C. Option A. C must be equal to A minus B in magnitude. Option B. C must be less than A minus B. Option C. C must be greater than A minus B. Or option D. C may be equal to A minus B. What does this mean? Compare C squared with A minus B squared at exactly 120 degrees. By the parallelogram law, with cosine of 120 equal to minus a half, C squared is A squared plus B squared minus AB. Subtract the square of A minus B. The difference is AB, which is positive for non-zero vectors, so C is always greater. Hence, C must be greater than the magnitude of A minus B. Option C. Question 4. About the x component of the resultant of several vectors. Option A. It is equal to the sum of the x components of the vectors. Option B. It may be smaller than the sum of the magnitudes of the vectors. Option C. It may be greater than the sum of the magnitudes. Or option D. It may be equal to the sum of the magnitudes. What does this mean? Components add. Each component is at most the magnitude. Vector addition is component-wise, so option A is simply the definition. Correct. Each x component is at most its vector's magnitude, so the sum of components never exceeds the sum of magnitudes. Option C is impossible. A tilted vector's component is less than its magnitude, so the resultant's x component can be smaller than the sum of the magnitudes. Inequality happens when every vector lies along the x-axis, so option D is also possible. Hence, the answers are options A, B, and D. Question 5, the last objective. The magnitude of the vector product of two vectors may be option A, greater than AB, option B, equal to AB, option C, less than AB, or option D, equal to 0. What does this mean? The cross product's magnitude is AB sine theta. Sine runs from 0 to 1. The magnitude of the vector product is AB times sine theta, and sine theta lies between 0 and 1. At 90 degrees, sine is 1. The product can equal AB. At any other angle, sine is smaller. The product can be less than AB. For parallel vectors, sine is 0. The product can be 0. And since sine never exceeds 1, it can never be greater than AB. Hence, the answers are options B, C, and D. And now the exercises, 35 questions covering vectors, calculus, and significant figures. Here is the full list exactly as in the book. Pause here if you would like to attempt them first. Then let us solve them, one by one. Exercise question 1. A vector A makes an angle of 20 degrees, and B makes an angle of 110 degrees. With the x-axis, the magnitudes of these vectors are 3 meters and 4 meters, respectively. Find the resultant. What does this mean? We must add the two vectors and give the resultant's magnitude and direction. We are given A, 3 meters at 20 degrees, and B, 4 meters at 110 degrees. We have to find their resultant, r equals A plus B. The angle between the two vectors is 110 minus 20, which is 90 degrees. They are perpendicular. For perpendicular vectors, the parallelogram law reduces to Pythagoras. Root of 3 squared plus 4 squared, which is 5 meters. For the direction, tangent alpha is B over A, 4 over 3, so alpha is 53 degrees from A. Hence, the resultant is 5 meters. At 20 plus 53, that is 73 degrees with the x-axis. Question 2. Let A and B be the two vectors of magnitude 10 unit each. If they are inclined to the x-axis at angles 30 degrees and 60 degrees, respectively, find the resultant. What does this mean? Two equal vectors, 30 degrees apart, we need the single vector equivalent to both together. We are given A, 10 unit at 30 degrees, and B, 10 unit at 60 degrees. The angle between them is 60 minus 30, 30 degrees. By the parallelogram law, the resultant is the root of A squared plus B squared, plus 2AB cosine theta. Substituting, root of 100 plus 100 plus 200 cosine 30, which is 20 cosine 15, about 19.3 unit. Since the magnitudes are equal, the resultant bisects the angle between A and B. It lies at 45 degrees with the x-axis. Hence, the resultant is 20 cosine 15, about 19.3 unit, at 45 degrees with the x-axis. Question 3. Add vectors A, B, and C, each having magnitude of 100 unit. Incline to the x-axis at angles 45 degrees, 135 degrees, and 315 degrees, respectively. What does this mean? We must find the single resultant of all three vectors. We are given three vectors of 100 unit each. A at 45 degrees, B at 135 degrees, and C at 315 degrees. Now observe. 315 degrees is 135 plus 180, so C points exactly opposite to B. Equal and opposite vectors cancel. B plus C is the 0 vector, so the resultant is just A. Hence, the resultant is 100 unit, at 45 degrees with the x-axis. Question 4. Let A equal 4I hat plus 3J hat and B equal 3I hat plus 4J hat. Find the magnitudes of A, of B, of A plus B, and of A minus B. What does this mean? 4 lengths, each from the root of the sum of squared components. The magnitude of A is the root of 16 plus 9, which is 5. And B, root of 9 plus 16, is also 5. A plus B is 7I hat plus 7J hat, with magnitude 7 root 2. A minus B is I hat minus J hat, with magnitude root 2. Hence, 5, 5, 7 root 2 and root 2. Question 5. From the figure, we must find the magnitude, the x and y components, and the angle with the x-axis of the resultant of 3 vectors: OA 2 meters at 30 degrees, BC 1.5 meters at 120 degrees, and DE 1 meter at 270 degrees. What does this mean? Add the 3 by components, then rebuild magnitude and angle. Add the x components: 2 cosine 30 plus 1.5 cosine 120 plus 1 cosine 270. That works out to 0.98 meters. And the y components: 2 sine 30 plus 1.5 sine 120 plus 1 sine 270. That gives 1.30 meters. The magnitude is the root of 0.98 squared plus 1.30 squared, about 1.6 meters. And the angle with the x-axis is tan inverse of 1.30 over 0.98, which is tan inverse 1.32. Hence, magnitude about 1.6 meters, components 0.98 and 1.3 meters, at tan inverse 1.32 with the x-axis. Question 6. 2 vectors have magnitudes 3 unit and 4 unit. What should be the angle between them? If the resultant is 1 unit, 5 unit, or 7 unit, what does this mean? Solve the parallelogram law for theta in each of the 3 cases. By the parallelogram law, r squared is 9 plus 16 plus 24 cosine theta, 25 plus 24 cosine theta. For r equal 1 equals 25 plus 24 cosine theta, so cosine theta is minus 1. Theta is 180 degrees. For r equal 5, 25 equals 25 plus 24 cosine theta, so cosine theta is 0. Theta is 90 degrees. For r equals 7, 49 equals 25 plus 24 cosine theta, so cosine theta is 1. Theta is 0. Hence, 180 degrees, 90 degrees, and 0 degrees. Question 7, the spy report. The car moved 2 kilometers towards east, made a perpendicular left turn, and ran for 500 meters, then a perpendicular right turn, ran 4 kilometers and stopped. What does this mean? East, then north, then east again, we need the net displacement. Let east be x and north be y. The legs are 2 kilometers east, 0.5 kilometers north, and 4 kilometers east. Adding 6 kilometers east and half a kilometer north. The magnitude is the root of 36 plus 0.25, which is 6.02 kilometers. Its direction is tan inverse of 0.5 over 6, that is tan inverse of 1 over 12, north of east. Hence, the displacement is 6.02 kilometers, at tan inverse 1/12 north of east. Question 8, the carom board. A 4-foot by 4-foot square board has the queen at the center. The queen moves to the front edge, rebounds, and goes into the hole behind the striking line. We need her displacement: center to edge, edge to hole, and center to hole. What does this mean? A reflection problem. Equal angles at the edge fix where she strikes it. Take the center as origin. The front edge is the line y equal 2, and the hole is at the corner, 2, minus 2. Let the queen strike the edge at P, x, 2. Equal angles of incidence and rebound give, by similar triangles, 2 over x equals 4 over 2 minus x plus. Solving with the reflected image of h, x is 2/3. Center to edge, root of 4/9 plus 4, which is 2/3 root 10 feet. Edge to hole, root of 2 minus 2/3 squared plus 4 squared, 4/3 root 10 feet. And center to hole directly, root of 4 plus 4, which is 2 root 2 feet. Hence, 2/3 root 10, 4/3 root 10, and 2 root 2 feet. Question 9. The mosquito net. A net over a 7-foot by 4-foot bed is 3 feet high. A mosquito enters through a hole at one corner of the bed and sits at the diagonally opposite upper corner of the net. We need the magnitude of its displacement and its components along the bed's length, width, and the vertical. What does this mean? The body diagonal of a 7 by 4 by 3 box, with the hole as origin, length along x, width along y, and up along z. The far upper corner is at 7, 4, 3. The magnitude is the root of 49 plus 16 plus 9, which is root 74 feet. And the components are simply 7 feet, 4 feet, and 3 feet along the 3 axes. Hence, root 74 feet, with components 7, 4, and 3 feet. Question 10. Suppose A is a vector of magnitude 4.5 unit, due north. What is 3a, and what is minus 4a? What does this mean? Scalar multiples scale the length, a negative flips the direction. 3a has 3 times the magnitude, same direction, 13.5 unit due north. Minus 4a has 4 times the magnitude and the opposite direction, 18 unit due south. Hence, 13.5 unit north and 18 unit south. Question 11. 2 vectors have magnitudes 2 meters and 3 meters at 60 degrees to each other. We need their scalar product and the magnitude of their vector product. What does this mean? One uses cosine of the angle, the other uses sine. The scalar product is 2 times 3 times cosine 60, which is 6 times a half, 3 meters squared. The vector product's magnitude is 2 times 3 times sine 60, 6 times root 3 over 2, which is 3 root 3 meters squared. Hence, 3 meters squared and 3 root 3 meters squared. Question 12. The regular hexagon, A1 through A6. We write the x components of the 6 sides, taken in order, and use the fact that the resultant of the 6 vectors is 0, to prove that the 6 cosines, 0 through 5 pi by 3, add to 0. What does this mean? A closed polygon's sides sum to the 0 vector, so their x components must cancel. Each side has the same length, say L, and successive sides turn by 60 degrees. Their directions are 0, pi by 3, 2 pi by 3, pi, 4 pi by 3, and 5 pi by 3. So the x components are L cosine 0, L cosine pi by 3, up to L cosine 5 pi by 3. The loop closes, so the 6 vectors add to 0, and in particular their x components add to 0. Dividing by L gives the identity. Verify with known values. 1 plus a half minus 1 minus a half plus a half, total 0, hence proved. Question 13. Let A equal 2i hat plus 3j hat plus 4k hat, and B equal 3i hat plus 4j hat plus 5k hat. Find the angle between them. What does this mean? The dot product formula gives cosine theta. The dot product is 6 plus 12 plus 20, 38. The magnitudes are root 29 and root 50, whose product is root 1450. So cosine theta is 38 over root 1450, and theta is cos inverse of that. Hence, the angle is cos inverse of 38 over root 1450. Question 14. Prove that A dot A cross B is 0. What does this mean? A short proof from the direction of A cross product. By definition, A cross B is perpendicular to both A and B. The dot product of perpendicular vectors is 0, so A dot A cross B vanishes. Hence proved. Question 15. A is 2i hat plus 3j hat plus 4k hat, and b is 4i hat plus 3j hat plus 2k hat. Find a cross b. What does this mean? Expand the determinant with I, j, k in the first row. Set up the determinant with the unit vectors in the first row and the components below. The I component is 6 minus 12 minus 6. The j component is minus 4 minus 16 plus 12. The k component is 6 minus 12 minus 6. Hence, A cross B is minus 6i hat plus 12j hat minus 6k hat. Question 16. If A, B, C are mutually perpendicular, show that C cross A cross B is the zero vector. And is the converse true? What does this mean? Think about which direction A cross B points. A cross B is perpendicular to both A and B. With all three mutually perpendicular, C is also perpendicular to A and B. C must be parallel to A cross B. The cross product of parallel vectors is 0, hence proved. The converse asks, if C cross A cross B is 0, must the three be mutually perpendicular? No, it only forces C parallel to A cross B. A and B themselves may be at any angle. Hence proved, and the converse is not true. Question 17. A particle moves along a fixed straight line with constant speed v. P is its position, and O is a fixed point. We must show that OP cross V does not depend on where P is on the line. What does this mean? The cross product should come out the same for every point of the line. The magnitude of OP cross V is OP times V times sine theta, where theta is the angle between OP and the line. But OP sine theta is the perpendicular distance d from O to the line, which is fixed, whatever P we choose. So the magnitude is Vd, constant, and the direction, perpendicular to the plane of the line and O, is also fixed, hence proved. Question 18. The force on a charged particle is QE plus QV cross B. E is along the x-axis and B along the y-axis. In what direction, and with what minimum speed, should a positive charge move so the net force is 0? What does this mean? The magnetic force must exactly cancel the electric force. For 0 net force, QV cross B must equal minus QE. V cross B must point along minus x with magnitude E. Try V along the z-axis. Z hat cross y hat is minus x hat. That is exactly the direction we need. The magnitude gives VB sine 90 equal E, so V equals E over B. Sine is largest at 90 degrees, so this V is the minimum. Hence, along the z-axis, with minimum speed E over B. Question 19. Give an example where A dot B equals C dot B, yet A is not equal to C. What does this mean? Dot products do not cancel. Equal projections need not mean equal vectors. The condition says A minus C is perpendicular to B. So pick B along X, and let A and C differ by a vector along Y. For example, B is I hat, A is J hat, C is K hat. Then A dot B and C dot B are both 0, but A and C are different vectors. Hence, this example works. Equal dot products with B, unequal vectors. Question 20. We draw the graph of y equal 2x squared with tangents at x equal 2, 4, 6, and 8. We must find the slopes of these tangents and verify that the slope is dy by dx, which is 4x. What does this mean? The measured slope of each tangent should match the derivative. Differentiating y equal 2x squared gives dy by dx equal 4x, the tangent slope at any x. At x equal 2, the slope is 8, at 4 it is 16, at 6 it is 24, and at 8 it is 32. Drawing the tangents on the graph and measuring rise over run reproduces these same values, verifying tan theta equal 4x. Hence verified. Question 21. The curve is y equals sine x. X changes from pi by 3 to pi by 3 plus pi by 100. We need the approximate change in y. What does this mean? A small change. Delta y is the derivative times delta x. For a small change, delta y is approximately dy by dx times delta x, and the derivative of sine is cosine. At x equal pi by 3, cosine is a half, and delta x is pi by 100. Delta y is half of 0.0314, about 0.0157. Hence, y increases by about 0.0157. Question 22. The current in a charging RC circuit is I equal I naught, e to the minus t by RC. We need the rate of change of current at t equals 0, at t equal RC, and at t equal 10 RC. What does this mean? Differentiate the exponential, then substitute 3 times. Differentiating. di by dt is minus I naught over RC times e to the minus t by RC. At t equals 0, the exponential is 1. The rate is minus I naught over RC. At t equal RC, the exponential is 1 over e, minus I naught over RCe. At t equal 10 RC, it is e to the minus 10, minus I naught over RC e to the 10. Hence, minus I naught over RC, minus I naught over RCe, and minus I naught over RCe to the 10. Question 23. The discharging RC circuit with I naught 2 amperes, R6 into 10 to the 5 ohms, and C half a microfarad. We need the current at 0.3 seconds, its rate of change there, and the approximate current at 0.31 seconds. What does this mean? First compute the time constant RC, then evaluate. The time constant RC is 6 into 10 to the 5, times 0.5 into 10 to the minus 6. 0.3 seconds. At t equals 0.3 seconds, t by RC is 1. The current is 2 over e amperes, about 0.74 amperes. The rate of change is minus I naught over RC times e to the minus 1, minus 20 over 3 e amperes per second. For 0.31 seconds, add the rate times 0.01. 2 over e, minus 20 over 3e times 0.01, which is 5.8 over 3e amperes. Hence, 2 over e amperes, minus 20 over 3e amperes per second, and 5.8 over 3e amperes. Question 24. Find the area under the curve y equal 3x squared plus 6x plus 7 between the ordinates x equal 5 and x equal 10. What does this mean? A definite integral from 5 to 10. The area is the integral of the curve from 5 to 10. The antiderivative is x cubed plus 3x squared plus 7x. At 10, 1,000 plus 300 plus 70, which is 1,370. At 5, 125 plus 75 plus 35, which is 235. The difference is 1,135. Hence, the area is 1,135 square units. Question 25. Find the area enclosed by y equals sine x and the x-axis from 0 to pi. What does this mean? The area of one full hump of the sine curve. The area is the integral of sine x from 0 to pi. The antiderivative of sine is minus cosine. Minus cosine pi plus cosine 0, which is 1 plus 1. Hence, the enclosed area is 2 square units. Question 26. Find the area bounded by y equal e to the minus x, the x-axis, and the y-axis. What does this mean? The area under the decaying exponential from 0 all the way to infinity. The area is the integral of e to the minus x from 0 to infinity. The antiderivative is minus e to the minus x. At infinity it vanishes, at 0 it is minus 1. The area is 1. Hence, the area is 1 square unit. Question 27. A rod of length L lies along the x-axis from 0 to L. Its linear density varies as ρ equal A plus Bx. We need the units of A and B in the standard system and the mass of the rod. What does this mean? Match units term by term, then integrate the density. Every term of A plus Bx must have density units. So it has units of density, kilogram per meter, and Bx too, so B is kilogram per meter squared. The mass is the integral of the density. Integral from 0 to L of A plus Bx dx. Integrating, a L plus BL squared over 2. Hence, a in kilogram per meter, B in kilogram per meter squared, and massa L plus BL squared by 2. Question 28. The momentum changes as dp by dt equals 10 newtons plus 2 newtons per second times t. Momentum is 0 at t equals 0. What is it at 10 seconds? What does this mean? Integrate the rate from 0 to 10. Integrate both sides from 0 to 10 seconds. The antiderivative is 10t plus t squared. At 10 seconds, 100 plus 100. Hence, the momentum at 10 seconds is 200 kilogram meter per second. Question 29. dy by dx equals x squared. Find y as a function of x. What does this mean? Integrate and do not forget the constant. Integrating x squared gives x cubed over 3 plus an arbitrary constant c. Hence, y is x cubed by 3 plus c. Question 30. Count the significant digits. In 1001, 100.1, 100.10, and 0.001001. What does this mean? Zeros between digits count, leading zeros do not, trailing zeros after a decimal point do. 1001, all 4 digits count, the zeros are between non-zero digits. 4. 100.1 has 4, and 100.10 has 5, because the trailing zero after the decimal is significant. 0.001001. The leading zeros only place the decimal. The significant part is 1001, 4 digits. Hence, 4, 4, 5, and 4. Question 31. A meter scale is graduated at every millimeter. How many significant digits can a length measured with it have? What does this mean? The count depends on how long the measured length is. The scale reads to 1 millimeter. A length of a few millimeters has 1 digit, tens of millimeters 2, hundreds 3, and up to 1,000 millimeters 4. Hence, the measurement can have 1, 2, 3, or 4 significant digits, depending on the length. Question 32. Round to 2 significant digits. 3,472, 84.16, 2.55, and 28.5. What does this mean? Keep 2 digits. Exact halves round to the even digit. 3,472. The third digit 7 rounds the 4 up. 3,500. And 84.16 becomes 84. 2.55 is an exact half. Round to the even digit 2.6. And 28.5, also a half, rounds to the even 28. Hence, 3,500, 84, 2.6, and 28. Question 33. A cylinder's length is 4.54 centimeters and its radius 1.75 centimeters, both from a slide calipers. Calculate its volume. What does this mean? Pi r squared L kept to 3 significant figures. The volume is pi r squared L. Pi times 1.75 squared times 4.54. That is 43.66 cubic centimeters. The data have 3 significant figures, so we keep 43.7. Hence, the volume is 43.7 cubic centimeters. Question 34. 3 thickness readings, 2.17, 2.17, and 2.18 millimeters. Find the average thickness. What does this mean? Average the three and keep the precision of the data. The average is 2.17 plus 2.17 plus 2.18 over 3. 6.52 over 3, which is 2.1733. The data are known to three significant figures, so the average is 2.17 millimeters. Hence, the average thickness is 2.17 millimeters. Question 35, the last one. The string measures 90.0 centimeters with a meter scale, and the bob's radius plus hook is 2.13 centimeters. From a slide calipers, we need the effective length. Suspension point to the center of the bob. What does this mean? Add the two, but keep only the precision of the coarser measurement. The effective length is the sum. 90.0 plus 2.13, which is 92.13 centimeters. But 90.0 is known only to 0.1 centimeter, so the sum must be rounded to one decimal place. 92.1. Hence, the effective length is 92.1 centimeters. That completes Chapter 2, Physics and Mathematics from Concepts of Physics by H C Verma, both objective sections and all 35 exercises. In the next video, we take up Chapter 3, Rest and Motion Kinematics. Thank you for watching. If this helped, do like the video, subscribe to Math is Beautiful, and share it with your friends.